Hello everybody, welcome to the Go language course. In this video, I'm going to discuss the use of closures in Go language. Before I do so, I have to include the main package at the beginning of the file, and I have to import the fmt package at the beginning so that I'm able to use the print line function coming from this package. And this is the closure that I'm going to discuss. And before discussing it, let me discuss the meaning of the closure first. So what is a closure? A closure is a nested function that references variables from the outer function. So I'm going to use an example to discuss the meaning of the nested function and the outer function. And the variables to be referenced can be the local variables or the function parameters of the outer function. And I will also show the meaning of this sentence by using an example. A closure would retain access to these variables even after the outer function has been closed. The nested function is closed over the variables. These are the meanings of the closure. So let us see how we can make a closure in Go language first. A closure is actually a function that returns a function. So when I have a function called multiplier here, I want to say that this multiplier function would return another function which accepts a certain integer and return another integer. Okay, so the outer function variable is the product here. So this product variable would refer to the outer function called multiplier here. And we can treat the product variable here as the local variable to the multiplier function. Okay, and after defining a local variable for the outer function, I can just try to return a function. That is the meaning of the closure here. The closure is just the return value of the multiplier function, which is actually a function that accepts an integer and returns another integer. So I want to return a function. That's why I have to say func here. And how can I make use of this return function? I want to multiply the product from the local variable of the outer function by x, which will be input by the closure. Okay, so the closure would just take a value called x, and this x will be interacting with the local variable of the outer function. Okay, and the implementation is like this. In my case, I want to multiply the local variable of the outer function called product by x. Okay, and the result will just return the product. Okay, which is the updated one. Okay, so let us see how we can call the closure. So here I would say that the output variable here is going to store the function returned by the multiplier function. Okay, so my product here will just mean the function returned by the multiplier function. Okay, so we can have a closure here. And when I want to call this closure, I just say my product 1. And then I'm able to print the result, which will be 1, because originally the product variable was 1, and after multiplying 1 by 1, which is coming from the closure, the result will be returned, which will just be 1. Okay, and when I finished the calling of the closure for the first time, I can also call the closure for the second time. Okay, the input here for the closure is now 2. So in this situation, this value of 2 will be multiplied by the value called product, which is stored in the outer function variable. But we have to notice something here. The product variable will be 1, and after multiplying 1 by 2 coming from the input of the closure, the product will become 2. But we have to notice here that the product used in the my product 2 closure here is actually the result coming from the first closure. Okay, so it is not so easy to see it because both the original local variable and the return value of my product 1 are both 1. But we will be able to see this effect more clearly when I use the closure for the third time by inputting 3 into the closure. So we remember that the closure got the product as 2, and this 2 will be remembered by the closure, and this closure will take 2 as the product here. When this product 2 is multiplied by 3, which is coming from the third call of the closure, 2 times 3 will become 6. So the product will become 6 rather than using the original value called 1, which is obtained from the very beginning of the function call. Okay, so let us see the result of this use of the closures for 3 times. Okay, you can see 1, 2, and 6 here. So this 6 is coming from 2 times 3. 2 is actually the product variable evaluated after the second call of the closure. So we can see that the product here, which is the local variable to the outer function, can be varied by the closure, and this variation will be remembered. Okay. And then we have to say something here. A new closure is made when the outer function is called again. What does it mean by the sentence? Let us see the meaning right now. So I have a variable to store the closure coming from the multiplier function. My product 2 here is actually the new variable that stores the closure. So this multiplier function will be placed into the my product 2. And when I do so, the closure is a really new one, in the sense that the result stored in the product variable here will no longer be 6. Okay, when I did my product 3 for the first function call here, I would have 6, but now when I use the function for the second time, all the memories will start again. Okay, so let us see the example here. My new product 2 followed by 1 will just be 1, because for the first call, the product variable was 1, and 1 times 1 coming from the closure will be just 1. And this product will have a value of 1. And when I call the closure for the second time, I will have 1 times 2, which will be equal to 2. So we can see that the memory is started again. So a new closure exists, and it has no relation to the previous closure that I created, even though I used the same outer functions. Okay, so let us see the result. Okay, you can see that for the first outer function call, I will have 1, 3, and 6 coming from the closure. But when I have to create a new closure, the new closure would just do its own thing, which is unrelated to the previous closure that I used. Okay, so you will see 1 and 2 again. So a new closure is made when the outer function is called again, and the new closure has no relation to the previous closure that I used. Okay. So this video has discussed the use of closures. It is just a function that outputs another function, and the closure will be independent of each other when I call the outer function once again. And we can see that the local variable inside the outer function can be remembered by the closure, even though the outer function is used already. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.